Okay, so first thing we're going to do is we're going to set up a diagram for the problem. First thing is you always want to do a picture of the problem, which will greatly simplify things. So we have this car traveling, and when the car is in motion, it has a velocity. They're using the word speed. Speed and velocity are almost interchangeable. You know, speed is scalar, velocity is vector. Here they're using the word speed because no direction is specified. All right, so while in motion, he's traveling at 89.5 kilometers per hour. That's his instantaneous velocity at any point in the journey. Okay, and then somewhere along the way, he takes a rest stop. So let's say that right here represents the rest stop. And the rest stop is, we're going to call that TR for time of rest, is 22 minutes. Now, minutes and hours, so the velocity is using hours. So what do we have to do to the minutes? Convert it to hours. So 22 minutes is the same as 0.36, 0.36 repeating hours. Okay, so after the rest stop, he keeps on driving again. What's his velocity while he's driving? 89.5, and then he gets to the end of his journey here. Okay, so the total displacement from here all the way over to the end, we'll label that as x. Okay, and then they tell us the other piece of information is that when he gets to the end of his journey, the average speed or the average velocity, little line above the V indicates average. The average for the whole trip is 77.8 kilometers per hour. Now, why is the average velocity for the whole trip less than his velocity while in motion? What accounts for that? The rest stop. The rest stop is what accounts for it. Okay, so this is our given. That's the given. What are we finding? So you go given, find, we're finding two things. What are the two things we're solving for? We want the time total, T total. Now what does T total mean? It means time of rest plus time in motion. So TM, I'm going to say that TM is time in motion, TR is time of rest. And then the second thing is the displacement. All right, so let's label TM as a question mark. So we're looking for the displacement and the time in motion. Because once we know the time in motion, we can find the total time by adding the time of rest. All right, any questions so far with the setup? All right, so the solution. The key to the problem, the key that unlocks this problem is writing equations for the velocity while in motion and velocity average. So no numbers here, just variables. So what's the basic definition of velocity? The basic definition of velocity is what? Displacement over time. All right, so velocity while in motion is going to be displacement divided by what time? Time of rest or time in motion? The time in motion, right? Because this is the velocity while in motion. So we have this equation. That make sense? This 89.5 kilometer per hour, if you take his total displacement and divide by the time while in motion, you know, that's going to give the 89.5 kilometers per hour. Okay, now what's going to be true for the average velocity? So again, we're going to take the total displacement and divide by what? Time in motion plus time of rest. So the denominator, is the time total, the total time for the whole journey. All right? Now, at this point, I would say the hard part is done. The hard part, this class should be challenging because of the physics involved. This class should not be difficult for you because of the math. If you find the math in here too difficult, you should level down to regular. That would be my advice. All of you should be comfortable with the math. The math that we do should not break your brain. It should be like, oh, okay, I can do that. But getting to this point, setting up these two equations, that's the physics of the problem. From here, what's the rest of the problem? From this point right here, what's the rest of the problem? Algebra. The rest of the problem is algebra. What we have here are two equations and two unknowns. What are the two unknowns? We're looking for two things: time in motion and displacement. If you have two equations and two unknowns, can you solve it? Yeah. So here's what I'm going to do. I'm going to take this equation here. So now work the algebra. Take that equation there. X equals v multiplied by t in motion. So I solved that for x. Then we take that equation and plug it back in over here, which is going to give us average velocity equals v time in motion divided by time in motion plus time of rest, and now cross multiply. We're going to take this denominator here and multiply both sides by it. So that's going to give us average velocity time in motion plus time of rest equals instantaneous velocity time in motion. We distribute this. I'm going to come up here. So we distribute that, so that now gives average velocity time in motion plus average velocity time of rest equals instantaneous velocity time in motion. So now we can get time of motion. So that's going to be, so we'll, we're going to go average velocity time of motion minus instantaneous velocity time of motion. Well, you know what? I'm going to do it the other way. I'm going to avoid the negative. So this is going to be so then time of motion is going to equal average velocity time of rest over yo.
Wouldn't the velocity of time of rest be negative to the other side?
I started to do that, but okay. So what I did right here is I took this. I took this guy right here, and I moved him to the other side. Moved him over there, which made him minus. And then this stayed positive. That stayed positive. Okay, so now we plug numbers in. I'm running out of room here. So the average velocity is 77.8 kilometers per hour. The time of rest is 0.36 repeating. And then we go 89.5 kilometers per hour minus 77.8 kilometers per hour. So then this gives a time of motion equal to 2.44 hours. Okay, so what will the total time be? The total time, we're going to take the time of rest, take this rest time and add it to the time of motion, and then that's going to give us a total time of about 2.8 hours. When you add the time of motion to the time of rest, you get about 2.8. All right, so now that we know the time of motion, Now that we know the time of motion, we can find the displacement very easily. All we have to do is go to this equation right here, go to this equation, and solve for x. So let's take this up here. So x is going to equal instantaneous velocity multiplied by time of motion. So the instantaneous was 89.5 kilometers per hour, and then the time of motion was 2.44 hours. So then this gives us a displacement of 218.4 kilometers.